Summary. The main features of this chapter which we have studied are as follows. The magnetic flux through a surface of area A placed in a uniform magnetic field B is defined as phi B is equal to B dot A, that is equal to BA cos theta. Faraday's laws of induction. It implies that EMF induced in a coil of N turns is directly related to the rate of change of flux through it. That is, epsilon is equal to minus N into d phi B by dt, where phi B is the flux linked with one turn of the coil. If the circuit is closed, a current I equals epsilon by R is set up in it, where R is the resistance of the circuit. Lenz's law. It states that the polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces it. The negative sign in the expression for Faraday's law indicates this fact. When a metal rod of length L is placed normal to a uniform magnetic field B and moved with a velocity v perpendicular to the field, then the induced EMF, also called motional EMF, across its ends is epsilon is equal to BLV. Changing magnetic fields can set up current loops in nearby metal. They dissipate electrical energy as heat. Such currents are called eddy currents. Inductance is the ratio of the flux linkage to current. It is equal to N into phi divided by I. A changing current in a coil, say coil 2, can induce an EMF in a nearby coil, say coil 1. Then the relation is given by epsilon 1 is equal to minus M12 into d by dt of I2. This is called mutual inductance. The quantity M12 is called mutual inductance of coil 1 with respect to coil 2. One can similarly define M21. There exists a general equality, that is M12 is equal to M21. When a current in a coil changes, it induces a back EMF in the same coil. The self-induced EMF is given by epsilon is equal to minus L di dt, where L is the self-inductance of the coil. It is a measure of the inertia of the coil against the change of current through it. The self-inductance of a long solenoid, the core of which consists of a magnetic material of permeability mu r, is given by L equals mu r into mu naught into n square AL, where A is the area of cross section of the solenoid and L is its length. Here N is the number of turns per unit length. In an AC generator, mechanical energy is converted to electrical energy by virtue of electromagnetic induction. If coil of N turns and area A is rotated at N revolutions per second in a uniform magnetic field B, then the motional EMF produced is epsilon equals NBA into 2 pi V sine of 2 pi V t, where we have assumed that at time t equals to 0, the coil is perpendicular to the field. That's all. Surely you would have loved the chapter and mastered all the concepts.